Alright, this is the third and final part of a review on proving triangles congruent. In this video, we are going to do a couple of two-column proofs proving triangles congruent, and we are going to look at some constructions and see how we can identify what construction we were doing based on the markings. Were we copying a segment, copying an angle, were we copying a triangle by side angle side or side side side, etc. Alright, let's start with our two-column proofs. Before I start a two-column proof, I like to map out exactly what I'm going to do ahead of time. So let's see. They are giving us that WZ bisects angles XZY. Okay, so it's this angle. And bisect means to cut in half, two equal parts. So indirectly we have this. And it's bisecting angle XWY. So it's also bisecting this angle. So indirectly, alright, by the definition of angle bisector, we will also know that these are congruent. In addition to that, we know that the shared side, ZW, is going to be congruent to ZW by the reflexive property. So putting all that together, I can say that the two triangles are going to be congruent by the angle side angle postulate. Okay, and then that'll be what I'm trying to prove. So let me think ahead and see how many steps this is going to take. Alright, so first, none of these pieces of information, angle, side, or angle, none of those are given to me directly. So that means I'm going to have to start by stating what the given actually is. Alright, this is not the proof, I'm just planning it out. So first I'm going to state the given, which is like angle bisector. Alright, then I'm going to be able to break down and do a pair of angles, a pair of sides, and a pair of angles, because I'm doing angle, side, angle. Okay, once that's done, I can say that the one triangle is congruent to the other triangle by angle, side, angle. So this is going to take me 1, 2, 3, 4, 5 steps. Okay, so like I said, step 1 is going to be just to state the given. Alright, so I'm going to take this given and I'll just go ahead and get that out of the way as step 1. Alright, I had to write it kind of small, but I just wrote the given. So WZ bisects angle XZY and angle XWY, that's given. Alright, so now since I want to prove the triangles are congruent by angle, side, angle, then I'm going to use angle, side, angle to guide my proof. In other words, I'm going to make sure I have a pair of angles, a pair of sides, and a pair of angles next. So my first pair of angles, I'll do this pair right here. So I'm going to say angle XZW. Okay, angle XZW is congruent to angle YZW. Okay, and I knew those would be congruent because in the given we have an angle bisector, and that's the definition of angle bisector, that it's forming two congruent angles. So the reason will just be definition of angle bisector. Alright, so I'm doing angle, side, angle, so next I need a pair of sides. The pair of sides is the shared side. ZW is congruent to ZW, so I can say ZW is congruent to ZW. And of course that's going to be because of the reflexive property. Okay, and so finally I need a pair of angles again. So I did these angles, so now it's time to do these angles. So I can say that angle XWZ is congruent to angle YWZ. And again, that's the definition of angle bisector. Okay, so now that I've shown a pair of angles, a pair of sides, and a pair of angles are congruent, I can go ahead and say the thing I'm trying to prove, that the triangles are congruent by the angle-side-angle postulate. Okay, so I can say triangle WZX is congruent to triangle WZY by the angle-side-angle postulate. Okay, so that is your two-column proof for number 17. Alright, let's go ahead and look at number 18. Alright, this is looking pretty similar. Let's make our plan. They're telling us that C is the midpoint of both segments. Alright, if C is the midpoint, then by the definition of midpoint, we know that these will be congruent and these will be congruent. But we also know that these vertical angles are congruent because they're always congruent. So with that information, we will be able to say that the triangles are congruent by the side-angle-side postulate. Okay, so let's plan out our proof so we can see how many steps. None of these three pieces of information, side, angle, or side, is given in the given. So that means I'm going to have to state the given separately first. So I'm going to have to state the given, and then from there I'm going to have to come up with a pair of sides, a pair of angles, and a pair of sides. And once I've done that, then I can go ahead and say that the triangles are congruent. Okay, so that's going to take 1, 2, 3, 4, 5 steps. So it's going to be almost like the proof that we just did in number 17. In fact, I think I'll just copy and paste the little table here to help me out. Okay, so let's get started. Like I said, we're going to have to start with the given. Alright, so I'm just going to write this down as the first statement. Okay, so there I've stated the given. Alright, once I have that, then I'm going to need, since I know my goal is to prove the triangle is congruent by side, angle, side, I will use these three things to guide my proof. So I'm going to need a pair of sides, a pair of angles, and a pair of sides. I'm just matching the colors up with my picture. Okay, so it's time for a pair of sides. Now we were given that C is the midpoint. So that indirectly told us that, for example, AC would be congruent to CD. So it's time to say that. So segment AC is congruent to segment CD. Okay, so that's one pair of sides, and that is the definition of midpoint. Okay, now it's time for the pair of angles. Well, we knew that these were congruent. Angle ACB. Don't just say angle C. You can't call two different angles by the same name. So you have to use the three-letter designation and say angle ACB is congruent to angle DCE. And that's because of the vertical angle theorem. Okay, and then once again we need the other pair of sides. So BC is going to be congruent to CE. And again, that's definition of midpoint. Okay, once I have determined that I have a pair of sides, a pair of angles, and a pair of sides congruent, I can go ahead and say that the triangles are congruent by side angle side. So triangle ABC is congruent to triangle DEC. And that's by the side angle side postulate. Okay, so that is it for our two-column proof for number 18. Alright, in number 19 we're supposed to identify the construction. Okay, what do they mean by that? Well, here are some of the constructions that we've learned. We learned to copy a segment. Alright, that's the first thing we learned. We learned to copy an angle. Alright, then using those two pieces of information, we learned to copy a triangle by the side congruence. We learned to copy a triangle by side angle side. We learned to copy a triangle by angle side angle. Okay, and we also did hypotenuse leg, but you get the idea. So these are the types of things they're asking for. Did we copy a segment? Did we copy an angle? Did we copy a triangle? And if so, which three pieces of information did we use to do it? Okay, so number 19 should be pretty obvious because we have a segment and then we have a new segment. So it's pretty obvious that we're copying a segment. So that is the answer. That A is copy a segment. Alright, but just one more time, understand the markings. If I have a segment and I'm trying to copy it, then the first thing I do is I draw a longer segment, and then I use my compass and I take it and I set my compass to be the same length as my original segment, and then I take that and I move that to my new situation and I draw a mark like that. Okay, get out of there. Okay, and that shows me where to draw my new segment. Okay, so see this mark right here at the end of my new segment? That marking is what you're showing in this picture, okay, when you look at these markings right here. Okay, so that's what they're talking about. So focus on those marks, man. Now here we just have an angle, alright, so you could probably guess without even really analyzing the markings that this is a picture of the construction copy an angle. Okay, but once again, let's take a look at how we copy an angle so we can see where these markings are coming from. Okay, this mark and then this mark. Alright, because that's what we're looking for, is the markings. So, back to the drawing board. First, let me just draw a quick angle. Alright, so if I'm copying an angle, so here's a side and then here's another side. Okay, so if I'm copying an angle, the way I do that is first I take my compass, I put it at the vertex, and I draw myself a random arc, okay, intersecting twice. And then I'm going to take my straight edge, alright, and I'm going to start off with a side, okay, but then so I take my compass and let me put it back to the same. Is it still set? Maybe it's still set. So I'm going to take that same size marking and I'm going to make that same I meant for that to be green. I'm going to make that same marking. Alright, I'm copying it, but I don't stop there, because so far that's not enough. I have one side, I have no idea where to draw the other side. So the way I learn where to draw the other side is I take my compass and I measure from intersection point to intersection point. Okay, so then if I take that down here and I make an arc, alright, a little arc right here, then that is what shows me where to draw the other side of my angle. So it goes straight through there, and there I've copied the angle. But focus on the markings. See how I have an arc going through the angle and another little arc cutting across it, alright, centered at the intersection point. So arc and little cross arc, that's always the marking that you're going to see when you're duplicating an angle. Okay, so looking back at the lesson, you see the arc and then the little cross arc centered at G. That's what it looks like when you copy an angle. Alright, keep that in mind as we look at some of these other pictures. So here you see whole triangles. So probably we're talking about copying a triangle. But is it side, 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 angle, side, angle, side, angle? What's going on? Okay, now look, are any angles being copied? All right, look at what we just talked about. If we have an angle being copied, it's always going to have these markings. Well, the angle that you're copying is always going to have an arc around it, like the green, and then it's going to have a cross arc centered at the intersection. So arc, cross arc, that's what it looks like when you're copying an angle. Looking at C, do you see like an arc or a cross arc happening here? No, like none of these angles have the arc and the cross arc. Okay, if I had an angle being copied, I'm just sketching it freehand, so I don't have a compass here. So but just to give you the idea, I'd have like arc, and then there'd be like a cross arc, okay, happening. That's not happening. So none of the angles are being copied. So that means all that must have happened, because when you copy a segment, all you get is just the one arc, okay, showing how long the segment was. So what must have happened is it must be we must have copied the one segment, okay, and that's where this came from. Alright, and then we must have copied another segment, okay, and that's where this arc came from. And then we must have copied another segment, and then that's where this arc came from. Okay, so that's side, side, side. No angles, all sides. So that's why the answer is going to be that this is a picture of what it looks like when you copy a triangle by the side, side, side method. Alright, so this was copying a triangle by side, side, side. Okay, now look at D. Again, of course, we're copying a triangle. So copy a triangle by. Now by what? Are any angles being copied this time? All right, look around. Do you see any angles being copied? Sure you do. Okay. I'll just mark it with a highlighter. All right, this angle right here is being copied. All right, you can see what we talked about. This is what it looks like when an angle is being copied. You have an arc around it and then a cross arc centered at the intersection. So looking at this angle, you see an arc around it and then a cross arc centered at the intersection. So we have an angle. Do we have any other angles that are being copied? No. Alright, so the others are all sides. So fine. So we had this angle being copied, like you saw. And now looking at the other pieces, for example, this segment must have been copied because you can see the one arc. Alright, when you copy a segment, you only get the one arc. So this segment was copied here. Okay, and you see that this arc is centered on this point right here. So this segment must have been copied by using this arc, alright, to capture it. So what we have is a side, an angle, and a side. So I'm trying to see how I'm trying to match the colors so you can see what's happening. The arc shows you which side is being copied. Okay, so this little mark right here caps the end of this segment. This arc over here is capping off the end of this segment. Okay, so maybe I should color the whole thing. Maybe I should have done it like that. Okay, so anyway, side, angle, side is what we're talking about. Alright, that's going to be the end of this video. I'm going to make one more video because we have a review problem tacked on to the end of this that my students will be held accountable for. But if you're randomly watching this from YouTube or something like that and you're not one of my students, then you're not going to care about that because it has nothing to do with anything else. So let me stop this video right there, and I hope this has been helpful to you. I will see you on the next video.